What is this article? What is this study that was done by this unnamed or named hero? Well, I just so happen to have it, and we're gonna frickin' go over it. Article by Jeremy Wagner on August 19th, 2020. How did he come to such a conclusion about React? React is popular enough that it receives its fair share of criticism. Yet, this criticism of React isn't completely unwarranted. React and React DOM total about 120 KB of minified JavaScript, which definitely contributes to slow startup time. When client-side rendering in React is relied upon entirely, it churns. Even if you render components on the server and hydrate them on the client, it still churns because component hydration is computationally expensive. React certainly has its place when it comes to applications requiring complex state management, but in my professional experience, it doesn't belong in most scenarios I see it used. When even a bit of React can be a problem on devices slow and fast alike, using it is an intentional choice that effectively excludes people with low-end hardware. If it sounds like I have a grudge against React, then I must confess that I really like its componentization model. It makes organizing code easier. I think JSX is great. Server rendering is also cool, even if that's just how we say send HTML over the network these days. Still, even though I happily use React components on the server, or Preact as is my preference, figuring out when it's appropriate to use on the client is a bit challenging. What follows are my findings on React performance as I've tried to meet this challenge in a way that's best for users. Setting the scene. Lately, I've been chipping away at an RSS feed app side project called bylines.fyi. This app uses JavaScript on both the backend and front end. I don't think client-side frameworks are horrid things, but I've frequently observed two things about the client-side framework implementations I tend to run into in my day-to-day work and research. Frameworks have the potential to inhibit a deeper understanding of the things they abstract, which is the web platform. Without knowing at least some of the lower level APIs that frameworks rely on, we can't know what projects benefit from a framework and which projects are better off without one. Frameworks don't always provide a clear path toward good user experiences. You may be able to argue the validity of my first point, but the second point is becoming more difficult to refute. You might remember a little while ago when Tim Kadlec did some research on HTTP Archive about web framework performance and came to the conclusion that React wasn't exactly a stellar performer. We have been through, I think it might have been this exact article before. But essentially, this person broke down the cost of like what it costs in terms of size, right? Package size, okay, to serve up sites on particular frameworks. So bytes served to the desktop and mobile broken down. The execution time, right? jQuery, Vue, Angular, React being the worst offender. Scripting related time on desktop, and so on and so forth. This is an article that I'm pretty sure I've done before, but let's keep going. Still, I wanted to see if it was possible to use what I thought was best about React on the server while mitigating its ill effects on the client. To me, it makes sense to simultaneously want to use a framework to help organize my code, but also restrict that framework's negative impact on the user experience. That required a little experimentation to see what approach would be best for my app. The experiment. I made sure to render every component I use on the server because I believe that the burden of providing markup should be assumed by the web app server, not the user's device. However, I needed some JavaScript in my RSS feed app in order to get a toggleable mobile nav to work. Okay? So far, nothing crazy here. This scenario aptly describes what I refer to as simple state. In my experience, a prime example of simple state are linear A to B interactions. We toggle a thing on, then we toggle it off, stateful but simple. Unfortunately, I often see stateful React components used to manage a simple state, which is a trade-off that's problematic for performance. Though that may be a vague utterance for the moment, you'll come to find out as you read on. That said, it's important to emphasize that this is a trivial example, but it's also a canary. Most developers, I hope, aren't going to rely solely on React to drive such simple behavior for just one thing on their website. So it's vital to understand that the results you're going to see are intended to inform you on how you architect your applications and how the effects of your framework choices could scale when it comes to runtime performance. The conditions. My RSS feed app is still in development. It contains no third-party code, which makes for easy testing in a quiet environment. The experiment I conducted compared the mobile nav toggle behavior across 3 implementations. A stateful React component, rendered on the server and hydrated on the client, a stateful Preact component, also server rendered and hydrated on the client, and a server rendered stateless Preact component, which was not hydrated. Instead, regular old event listeners provide the mobile nav functionality on the client. Each of the scenarios were measured across 4 distinct environments: a Nokia 2 Android phone on Chrome 83, an Asus X550cc laptop from 2013 running on Windows 10. Windows 10 on Chrome 83, an old first generation iPhone SE on Safari 13, and a new second generation iPhone SE also on Safari 13. What was measured? Startup time, hydration time, mobile nav open time, mobile nav close time. It should be noted that measurements of these behaviors include scripting time only. Any layout, paint, and compositing costs would be in addition to and outside of these measurements. One should take care to remember that those activities compete for main thread time in tandem with scripts that trigger them. The procedure: remote debugging in Chrome, local network with toggling, throttling network performance, recording, profiling, and reloading the page. You'd open the mobile nav menu and then close it. You'd stop the profiler and record how much CPU time was involved in each of the 4 behaviors listed earlier. Then you clear the performance timeline and also click the garbage collection to free up any memory that's included. I repeated this procedure 10 times for each scenario for each device. 10 iterations seem to get just enough data to see a few outliers while getting a reasonably accurate picture, but I'll let you decide as we go over the results. If you don't want to play-by-play of my findings, you can view the results at the spreadsheet and draw your own conclusions, as well as the mobile nav code for each implementation. The results. Okay, so minimum, maximum, medium, average CPU times, right? Startup cost, Google Chrome on Nokia 2. React, Preact, add event listener code. The time differences between minimum, median, average, and maximum is wildly insane. This is one component. To remind you, startup cost in this case includes the time it takes for the browser to evaluate the scripts needed for the mobile nav to work. For React and Preact, it also includes hydration time, which in both cases can contribute to the uncanny valley effect we sometimes experience during startup. Preact is obviously a bit better. Okay, and then hydration cost alone. These numbers are wildly different. For React, this is still in the vicinity of yikes peak. Sure, a median hydration time of 70 ms for one component isn't a big deal, but think about how hydration cost scales when you have a bunch of components on the same page. Mobile nav open time. This is crazy. It's not even close. Like, it doesn't even hold a candle. This all started because someone got tired of writing add event listener a bunch of times at the top of a file. Yeah, that's exactly. Yes. A quick note on JavaScript samples. Before moving on to the iOS results, one potential sticking point I want to address is the impact of disabling JavaScript samples in Chrome DevTools when recording sessions on remote devices. After compiling my initial results, I wondered if the overhead of capturing entire call stacks was skewing my results, so I retested the React scenario samples disabled. As it turned out, the setting had no significant impact. How about Safari? It's not even it's not even close. It's not you've Doctor Stranged yourself into an entirely different universe. How about mobile nav open time? 24 times. How about Safari on second generation iPhone? Even worse. How about mobile nav open time? Nope. How about Chrome on a dated Windows 10 laptop? Get out. How about hydration time? Get out. How about mobile nav time? Get out. Shadow call stacks for the win. It's not a mystery as to why it takes React and Preact longer to start up than it does for a solution that eschews frameworks altogether. Less work equals less processing time. While I think startup time is crucial, it's probably inevitable that you'll trade some amount of speed for a better DX, though I'd strenuously argue that we tend to trade too much toward developer experience than user experience. Yes, those were an MS. That's right, Laugh. Yeah. The dragons also lie in what we do after the framework loads. Client-side hydration is something that I think is far too often abused and can sometimes be completely unnecessary. Every time you hydrate a component in React, this is what you're throwing at the main thread. Recall that on the Nokia 2, the minimum time I measured for hydrating the mobile nav component was about 67 ms. In Preact, for which you'll see the hydration call stack below, it takes about 20 milliseconds. Games have to run their entire code in less than 16 milliseconds tops. Yep. That's right. So he goes on about the call stacks. You can see a call stack of React firing a click event handler to open a mobile nav. This is what happens in the call stack in your CPU when you click a button to open that mobile nav that we saw that pulls in. That's React. That's what this does. Preact at least strikes the middle ground. This is less bad. And here it is. Plain old event listener. That's it. It gets the job done 7 times faster on the budget device than React. Conclusion. Well, it's not a React hit piece, but there are pitfalls. Right? And so he's trying to be fair here, and I get it. But this is what you're onloading. This is the cost of accepting libraries, frameworks, and languages that obfuscate or abstract things away. Right? There's a cost to that. Seems insane to me to think it's acceptable that one thing is allowed to take up to 14 milliseconds. Yeah, because nobody uses that, so no support. What do you mean, Ghost? Also, Sparrow, there's something no one mentions about this. Okay, hit me. What's up? Oh, Preact. Yeah, you're right, Ghost. Yeah. No single instruction takes this long to execute. Yes. This is exactly right. No single instruction takes this long to execute. How many instructions are being executed for these things? Well, we saw the call stack, didn't we? Like we literally looked at the call stack for it. So yeah, you have a very good point. It's a call stack with 1,000 functions. Yeah, this is the opposite of what should be done on my good evil scale. That I still have no name for it. Yeah, it is. It's not. It's a it's an extremely lazy and dangerous way to tackle these problems. In some cases, these things might be unavoidable, and you might have to reach out for something that does this in order to get this something done. It, there's no way I can say in whole like there is 100% never a reason to do this, but it is wild to me that this is defended as the de facto way to tackle problems like this over and over again.